Hello everyone. So in this video, I am going to go over how we factor trinomials. Trinomials are polynomials with three terms. And I am teaching the AC method of factoring. So you might have learned different methods from different teachers in your past. And if you have a method that works for you, I'm totally fine with you using that long term. But I do want you to watch this video and, learn from what I'm about to show you. So again, you're going to use this method when you have a polynomial with three terms. Whenever you're factoring, the first thing you always look for is a greatest common factor, no matter what you're factoring. And here, I've got a 3n squared, 32n, and 20. So I can't take an n out of all three of these, and there is no number that I can divide 3, 32, and 20 by. So I can't take a GCF out, so I'm going to go use trinomial factoring. So the first thing we're going to do is we're going to take this coefficient, the number in front of this guy, and this constant on the end, and we multiply them. All right. So I do 3 times 20. All right. And that gives me 60. So what this 60 number is this is going to be the number that I want to multiply to. And this number in the middle is going to be a number that I want to add to. So what I mean by this is we're going to first go ahead and list out all the different ways to multiply to get 60, okay? I recommend just starting with 1 and working your way up, right? You can get out your calculator. You can go, all right, 60 divided by 1. I know I can do 1 times 60. 60 divided by 2. Oops. I can do, 2 times 30. 60 divided by 3. I can do 3 times 20, 60 divided by 4. I can do 4 times 15. And again, these are all just ways to get to 60. 60 divided by 5, I get 5 and 12. 60 divided by 6, I get 6 and 10. 60 divided by 7. I get a decimal, so that's not a good, 7 doesn't work, so I go to 8. I'm going to do 60 divided by 8. That one doesn't work either, I get a decimal. And then I do 60 divided by 9. I get a decimal again. And then I'm going to go ahead and 10 is a number that I already found that is a factor, so I can stop there because I'm just going to get repeats at this point. So I've got all of my factors of 60 listed, all right? So now we're going to go ahead and look at our factors here, all right? So we're trying to multiply to a positive 60 and add to a positive 32. So now we need to go and look at all of these factors of 30 and, all of these factors of 60 and figure out if any of these pairings are going to add to this middle number of 32. So I look and I'm like, okay, well, 60 and 1 give me 61. 30 and 2 gives me 32. This is the guy that I'm interested in, all right? All these other ones don't give me a 32. I get, 19? I get 17. I get 60. Not 60, goodness, 16. All right, so my two magic numbers here are going to be 2 and 30. So now what I'm going to do is I'm going to rewrite this middle guy using my two magic numbers. So I do 3n squared plus 2n plus 30n plus 20. Now I'm going to go and do something that's called factoring by grouping. I look at these first two guys, all right? I'm like, okay, now I need to take out the greatest common factor of these two in this grouping. In this case, my GCF is just going to be n. I can't take anything, I can't divide 2 and 3 by anything other than 1, but I can take an n away from both of these. So I divide each of these by n, and on the inside, I'm going to be left with 3n plus 2. Then I look at my next grouping. My GCF between 30n and 20 is going to be 10. So I'm going to pull a 10 out, which means I have to divide each of these by 10. And I'm going to be left with 3n plus 2. Now, if you did this correctly, these two binomials here are going to match. If they don't match, something went wrong. Either you made a mistake, you didn't factor out a negative when you need to, maybe you didn't take out the greatest common factor, or maybe the polynomial just isn't factorable. So it just kind of, that signals something's wrong there. But in this case, they're matching, so I'm good to go. I look and I'm like, okay, so my final answer here, I'm going to take the two things that I took out as GCF. So I'm going to do n plus 10 and make a binomial. And then I'm just going to rewrite the binomial that was repeated, which is 3n plus 2. And this is my answer here. All right, so again, I took these two pieces, made a binomial, and then wrote the repeated one. Now, one nifty thing about this is you can always check your answer. This is my answer. And if I wanted to check it, I could go and FOIL this out. I distribute the n, I get 3n squared plus 2n. I distribute the 10, I get plus 30n plus 20. I combine my like terms and I get 3n squared plus 32n plus 20, which this matches what I started with. So this tells me that I did do it correctly. So keep in mind with these factoring problems, you can always just check yourself. All right, let's go ahead and try another one. So we look here. I look, do I have a GCF? No, I do not. So I'm going to go ahead and do my AC factoring. I multiply these guys. So I do 5 times negative 2, and that gives me a negative 10. So I know I have to multiply to negative 10 and add to 3. So before I deal with the fact that it's a negative 10, let's first just go and list out all of my factors of 10. All right, so we start with 1. So I do 10 divided by 1. It's going to be 1 times 10. 10 divided by 2. Oops. I get 2 and 5. 10 divided by 3. Doesn't work. 10 divided by 4. Doesn't work. I get a decimal. 10 divided by 5. I get 5 and 2, so now I'm repeating. Remember, once you start repeating, you've already found all of them. So these are all my factors here. Now, I'm multiplying to a negative 10, right? Because I had a 5 and a negative 2. So I need to multiply to a negative 10. Well, how do you get a negative? Well, when you're multiplying, you need one positive number and one negative number, right? So I know that one of these are going to be positive and one of these are going to be negative out of these pairings. And I'm trying to add to a positive 3, okay? So if I want two numbers to add to a positive and one has to be negative, I'm going to put the negative on the smaller guy. Because if I put the negative on the bigger guy, when I add them, I'm going to get a negative number. But I want to add them and get a positive number. So I'm going to put the negative on my smaller number here so that we add to a positive. So then we look, we can add these up. I get 9 here, which is not what I want. I wanted a 3. I add these up, I get a 3. So this guy's good. So I'm going to take these two magic numbers. I get 5r squared minus 2r plus 5r minus 2. Now, keep in mind, the order that you write these in actually doesn't matter. You could, in theory, you don't have to copy this down, but you could write like 5r squared plus 5r minus 2r minus 2. There's nothing wrong with that at all. You'll get the same answer. It's just like these intermediate steps will be a little bit different. So keep in mind, right, that the number that you write these two or the order that you write these two magic numbers in doesn't actually matter. All right, so now we go ahead, we have to look for, we have to do our factoring by grouping. We look for our greatest common factor. Well, 2 and 5, you can't really, they don't have a numerical common factor, but you can take an r out of both of these. So I'm going to divide both of these by r, and I get 5r minus 2. Now here, in the second grouping, these guys literally have no common factor. Okay, I have 5r and a negative 2. There's nothing I can divide 5 and 2 by other than 1. Now, when you're doing this factoring by grouping, you have to pull something out of the first group. You have to pull something out of the second group. So even though there really is no greatest common factor between these numbers, I'm still going to pull a 1 out. Okay, you got to pull something out when you're using this method. All right, and I look and these binomials match, which means I've done a good job. So I'm going to go ahead and take the two common factors here and make a binomial. So I'm going to do r plus 1. And then I'm going to write the repeated binomial once. All right, so this is my answer here. And of course, we can check our answer by multiplying this out. So I go ahead, I get 5r squared minus 2r plus 5r minus 2. I combine my like terms. And I look, that matches with what I started with, so I know that my answer is good here. All right, let's do one more. All right, So again, I look, do I have a GCF to take out? I do not. So I go ahead. Now, this guy doesn't have a number out in front here, but it's like an implied 1, right? We know that that's a 1 there. So if I do 1 times negative 12, I get a negative 12. All right. So I need to find two numbers that multiply to negative 12, and the number that's in front here is a negative 1. So I need to add to a negative 1. So I'm going to go ahead and list out my factors of 12 first. So I do 12 divided by 1. I know I can do 1 times 12. 12 divided by 2, I get 6. So I do 2 and 6. 12 divided by 3, I get 3 and 4. And then I start repeating, right? So I have already actually got all of my factors here. And I know I need to multiply to a negative. If I'm multiplying to a negative, I need one negative, one positive. So I know I need to slap a negative on one of these pairings. Since I want to add to a negative, I'm going to make my bigger number negative so that when I add these up, they add up to a negative. So here I get negative 11, which is no good. Here I get negative 4, which is no good. But here I get negative 1, which is what I want, right? We want these to add to a negative 1, that number in the middle. Even though there's no number there, we know it's an implied negative 1. So I get n squared plus 3n minus 4n minus 12. I'm going to go take out my GCF here. The only thing I can take out is an n. I divide each of these by n. I end up with n plus 3. Here, remember, if this leading guy is negative, we're definitely going to want to take a negative out because this first guy in the grouping is negative. And I look, I got 4 and 12, so I'm going to take a 4 out. I divide by negative 4, and I'm going to be left with n plus 3. These guys match up, so we are good to go. My final answer here is going to be n minus 4 and n plus 3. Of course, we can go and check. We FOIL this out. I get n squared plus 3n minus 4n minus 12. I get n squared minus n minus 12, which checks out with my initial problem. So that means I did a good job. So this is going to be my final answer here.